Alright, to start this lesson, we're going to go over the special quadrilaterals again. Yesterday we talked about parallelograms, which have opposite sides parallel, both sets of opposite sides. There were specific rhombuses where the sides are also congruent, rectangles where the angles were congruent, and squares where both the sides and the angles are congruent. The other special type of quadrilateral, remember a quadrilateral is a four-sided polygon. The other special kind is a trapezoid. Trapezoid has only one set of parallel sides, and we'll refer to those parallel sides as our bases. So the two sides that are parallel to each other are the bases for each other. There are other types of quadrilaterals. They may not have specific names, but if they don't have any parallel sides, they don't fall into our parallelogram or our trapezoid category. Over how to tell a parallelogram apart from a trapezoid. The most important thing is being able to tell them apart so you know which formula to use. So we talked about parallelograms yesterday. Remember, that one's pretty easy. It's just base times height. So you have to have the base, and remember the height has to be coming out at a right angle. So the area of this would be 10 times 3, which is 30 inches squared. Okay. As a reminder, remember when you're doing the perimeter, the 3 is not factored in. You have the 10, 5, 10, also 30, coincidental. Trapezoid is a little trickier. So a trapezoid, remember, only has one set of parallel sides. And the first thing is that since the bases are different, notice over here we have the same bases. Well, the bases are different over here. So we need to figure out the average of the bases. So we have base 1 and base 2. It doesn't really matter which. 8 plus 12 is 20. Okay? And we're going to take the average of them, so we're going to divide by 2. So the average of our bases is 10. Okay, so we're going to use that as our base and multiply that by the height of 5. So our area is 50 centimeters. You could use this formula on the parallelogram, it's just kind of pointless. If I added up 10 and 10 and got the average, by 2 is 10 again. So you're just kind of going in a circle, coming back at 10 again. So this idea, it's the base times the height for both of them. Only on this one, since there's two different bases, we average the bases instead of just using one of them. Okay? Same thing with the perimeter. We also just add up the sides again, not factoring in the height. So we do 7 plus 7 is 14, plus 12 and 8 is 20, so that's 34. Okay, so both of them, the only difference is since the trapezoid has two different bases, we average the two bases first and multiply that. About some irregular figures. This is a quadrilateral. The problem is it doesn't fall into the parallelogram or the trapezoid category. It doesn't have any sets of parallel sides. So in this case, there's no formula to use. All we can do is split up into shapes that we're more familiar with. In this case, I would split up into two right triangles. If I were to do a little dotted line along, you see that here's triangle 1, here's triangle 2. Okay, make it a little darker. I'm not sure it's showing up well. Okay. Starting with triangle 1, remember our triangle formula is base times height divided by 2. Do the two sides that are forming a right angle, the 6 and the 3. So 6 times 3, 2. So we get triangle 1, its area is 9. We'll make these centimeters. So we have some units. While triangle 2, we have base is 7, height is 2. We get 14, but remember, divide by 2. We get 7 centimeters. So at this point, since we found two separate triangles, the whole area altogether would just be the sum of that. 16 centimeters squared is the area of our two figures combined. So anytime you have an irregular figure like this that doesn't fall into one of our shapes categories for the area formulas, split it up into the shapes that we're more familiar with.